Today, we are going to take a look at a dynamic in context learning system that I built. This system is designed to tackle problems that are difficult by trying to learn the algorithm that might solve it, actually. As you can see from this graph, each one of these little dots that you see in the blue line is actually the agent, the system, actually learning something new about the solution, and therefore its accuracy improves. The red line is a rolling window accuracy, which counts the last 20 instances. We will be covering multiple files because I have different versions of these, and we will be dealing with this data set, which already has the labels here. So this actually is a challenge from Kaggle, the Spaceship Titanic challenge. So normally, to solve a challenge like this, we would have to build machine learning algorithms that would actually figure out the relationships with these features and try to predict the so-called label. But in this example, we are actually relying on the large language model itself to actually come up with a strategy or algorithm to actually find the relation that represents the relationships between these features and try to predict the outcome. So that's why I call this the dynamic in context learning, because essentially, if we look at this one example, the agent tries to create the algorithm. For example, the rule one, if cryosleep is true, if condition is cryosleep true, then transport it true. So it tries to create these rule sets to actually solve this challenge. And then we give it additional new information and more rows of informations, and then let it update its beliefs or the algorithm that it has come up with, or the rule set, or the prediction metrics. And I've done this with two different system messages, one that is more verbose and elaborate, and another one that is actually much more concise. So I was trying to find a sweet spot to do this. And we're going to talk more in depth about all this, but let's go ahead and run one example, and then we'll go over the scripts and then take a look at the actual running of it. By the way, the code files for this will be available at my Patreon for paying members, and the link will be below, depending on where you're watching this from. Just take a look at the comments or the description, and you'll be able to find it. Now, this script can use either OpenAI or OpenRouter. You can set it up, everything automatically adjusts. You can use any OpenRouter model or OpenAI model. You can set your reasoning effort, but so since we have a CSV dataset, but I do want to clarify that this is a challenge from Kaggle, but it doesn't have to be in this format. As long as you have, like, you can think of it like this: as long as you have rows of data which you yourself can actually create, and as long as those rows, even they might be just natural English, as long as they have a corresponding outcome, output, or a label, or a verifiable outcome, right? Then you can actually run this type of algorithm. And if you do get the code, you can actually quickly modify it to suit your needs. And I will be exploring more of the use cases. But let's go back to the code. So here we are. We can select the first rows to analyze. So this is the initial rows for matrix generation. We can give it any amount of number here. And so the first metric prediction matrix generation will be done with that. And then after that, uh, let me actually move this to the side. After that, we will select the number of rows to predict. So you can also enter here multiple numbers. For example, in this case, we will try to, after forming the prediction metrics, we will try to predict the next row and then the next row one at a time. And as long as it's guessing correctly, then it goes on. But if it guesses negatively, then we send that row back and ask it to reevaluate its prediction metric, and then it then writes a new one. And then when that happens again, it writes a new one. And if you look at these numbers here, let me zoom in a little bit. For example, right after the first initial iteration, uh, it guessed the next one right, the index one, and then it failed on index two, so it updated its beliefs. and then it was able to correctly guess the next three, and then failed at five, six, and seven, but then able to guess eight right. Right. So this is how it works. So you can actually modify this, and you can also set an iteration number. This is how I did it. So this will run for 500 iterations, for example. Although this training CV, let me bring it here, is actually quite long. I think it's 8,000 rows. So you can instead modify this to set some kind of a accuracy metric, if you like. So some of you may know, actually, I tried to tackle this with my O1 data scientist and later the GPT-5 data scientist. And I think the latest, the Grok Code Fast 1 data scientist, which actually does really, really well. With my Grok Code data scientist, I was actually able to score 223rd, actually, no, 34th. Uh, and this was pretty good for me. I mean, this is pretty good because there's 1,600 entries, and Grok Code actually was the best performing one. But that code, which you can also download from Patreon, I'll put the link in the description, was actually a script which allowed the large language model to write the machine learning code, the script which contained machine learning solutions to actually figure the relationship between the features. So that was just writing a script and running it and trying to improve on it, and that actually works to a great extent. But this is totally different from that, as we are relying on large language model to come up with a natural language description of the algorithm itself, and this also works. Okay, so like I said, let's run it. Let's run it actually with Grok Code Fast, because that actually is the one that does well. Let's set the first rows to analyze to 10, and let me set the prediction folder to just test, so that we'll be able to see it, and then we'll come back to the terminal and see how it works. As you can see, prepare 10 rows for metrics generation, and it's working on that. So, like I said, there is multiple different scripts here. The first one was bulk prediction. So with this script, you can actually give it a certain amount of rows to analyze, and then predict the so many rows after that. So in essence, we are giving here in this case Grok 4 500 rows from this data set, and then asking it to predict the next 50. Actually does pretty well. So let's take a look. So these JSON files are some of the results, and I'll include this in the download as well. And you can actually take a look at the terminal as well if you like, and I'll explain that here in a moment. But if you look at some of the results, like if you look at GPT-5, when we gave GPT-5 mini, I think this is the full GPT-5, or maybe the mini. Maybe I made a mistake. When you give it 500 rows and ask it to predict 50, it got 68%. That's pretty good. Here, when we gave GPT-5 minis 2,000 rows and asked it to predict the next 50, it got actually 74%. So that's very good. Here, Grok, with 500 input and 50 to predict, did actually 78%. So 78% is very respectable. If you come here, like if you get 78%, I think you would find yourself right in the middle somewhere, a little bit maybe below the middle. But it's actually pretty good, just because it's predicting it from its latent representation, perhaps. So that's what the bulk does. So after that, I wanted to create I had this idea of this single prediction, and I wrote the single py file, which automatically predicts. It's this exact same idea, but it predicts one at a time. But then I thought, well, what if to speed up the process? Because if we at this point, let's take a look here, because this is how the single progressive prediction engine script would have run. As you can see, it processes the first 20 predictions, and if you look here, it creates this description to predict future rows when presented with unseen information, and then it goes on to predict, and it actually predicts the first one correctly, and then moves on to the second one. It makes an incorrect prediction, and then it goes on to adjust its prediction metrics. and then goes on, and we are actually in real time drawing the plot for it as well, right? So this is how it works: the single prediction. So the batch prediction, actually, which is the one that we are running, can actually you can actually adjust the number of rows to predict. And the batch alternative is essentially has a more concise system message, which produces rather more concise prediction metrics like these versus these really long ones. I think the long ones does better from my experiments. But so this is in essence how it works, and I'll put the progress over here. So as we are going, you can see it update in real time. So those are the scripts, and like I said, you'll be able to download these from Patreon. By the way, when you're at my Patreon, just take a look around. I have over 400 interesting and fun large language model powered applications, such as this one. And as a paying patron, you'll be able to download all of them. Also, be able to speak with me on Sundays. We have weekly meetings. And I also have consulting tiers if you need any help with your projects, or you want to learn more in depth about this stuff and wanted to talk to me, you can actually do that via the consulting tiers at my Patreon. Anyway, coming back to this, if we take a look at some of these folders, as you can see, let's take a look at this. So here, Grok was doing one row predictions, and this was the chart we originally looked at, and this showed promise that so this is actually pretty big in my mind, because this shows that these models can actually learn in context from new information. So, but if you look at some other examples, so I was getting mixed results. So this one is positive as well. So where it's predicting 10 rows here, 20 rows, but this almost like it improves at first, then plateaus and goes down. And there are examples of this. So it doesn't always. So this is actually a slightly positive one. But let's take a look at this one, for example. Let's see. So this kind of plateaued, like this stayed steady. And there are some examples. Let's take a look at this one. It actually can go down. I hope I can find. Yeah. Well, this is the one where this one got cut off. But let's take a look at this one. Yeah, this one is play. So it's actually pretty good. It's either plateauing or improving, but there are examples where it actually goes down, like this one. So my interpretation of this is that what's going on is like let's figure this out. So imagine we are giving it the initial rows, right? Initial rows, and it learns from this. And then we are asking it to predict the next row, and then the next row after that, so on and so forth, right? Okay. So after the initial row, it creates, some kind of a knowledge base, let's say, the prediction metrics, and it applies it to this, the first one. If this is true or correct, then that's good. That's good. That's a check mark. So we pass that. But here, maybe it fails. So it wants to update this. So it updates it to a new one, new one. But in this case, it doesn't have access to the initial rows. That's the way I designed it. And most of the time, this serves to improve this secondary, like consecutive prediction metrics. The so-called, what I call is the algorithm, the natural language algorithm that the model generates. But I think sometimes it drifts. Sometimes it loses touch with the original idea, or it forgets the initial rows. So I'm going to actually try to improve the system with some kind of like residuality, occasionally doing backtesting, perhaps. But that's for another time. My impression is that this actually works. It's like and this to me seems a pretty big deal. And I'm going to work on this more and see what comes of it. Maybe let's take a look at the system messages real quick. Here we have, I believe, three different system messages. One is to generate predictive metrics. You're analyzing a spaceship Titanic data set. You can actually change this to be more meta, like more general. But in this case, I wanted to just see what would happen. Information about the data set, and then asking it to look and create comprehensive predictive metrics that would include key patterns and correlations, detailed decision rules, which we see. If you look, see, these are the rules: probability estimates, statistical insights, confidence levels, special considerations, so on and so forth. And then we have the predict single row, which allows us to predict a single row. And then after that, we have a third part where we adjust the metrics that a prediction error has occurred. We give it the current metrics, we give it the necessary data, and pass it all the information necessary, and ask it to actually revise the current metrics. We are giving it the current metrics, but like I mentioned before, we are not passing the initial rows. So that's I think what sometimes causes drift or divergence, in my opinion. So this is roughly how it works. And if you look at the plot, so you can see the blue line, which is the current cumulative, and the red one being rolling, which is currently set to 20, past 20 instances, diverge. At this point, you would expect the current rolling average to spike and then the red to follow it, almost like a rolling, kind of like a 20-week um, average in the stock market or something like that. Because you're expecting the probability, so the accuracy to rise over time, and you can actually see it happening often. Is the case, not initially perhaps, but over time. We are, after all, doing single row predictions on a data set that has 8,000 rows, right? So I'm in the early stages of exploring this concept. So if you like this content, if you're watching this from YouTube or Twitter, follow or subscribe, and I will definitely be doing more updates on this. Okay, thank you for watching, and don't forget to check out my Patreon and see if you like what you see there. And the code files for this project, along with all the previous metrics and results, will be available at my Patreon as well. You can find the link for that in the description or the comment below, depending on where you are watching this from. Take care and see you in the next video.